Hi, everybody. My name is Creasy. I'm an engineer at Comcast, and I want to welcome you to my talk on architecture design for design systems. I've worked on this library for almost 5 years, beginning as we were abandoning XML UI components for composed components. So on the agenda today, I wanted to briefly start off by defining a design system for you and explain its benefits and who are our target users. Then we'll move into the heart of the talk and discuss my team's approach to the architecture we use in our design library. And after that, we'll dive into the importance of API design and give you guys some examples of what we do. Finally, we'll go over some lessons that we've learned throughout our experience building and maintaining our design system. So what is a design system? For those of you who don't know, it's a library that contains tokens and components and are shared across different features of an app. So when I say tokens, I'm referring to a set of values like colors, icons, spacing, or typography styles. These values are the foundation for all styling throughout our app and establish a common look and feel that connects every screen together. Components are the small building blocks we use to build out screens that have both content and interactions. Common examples include buttons, checkboxes, radio buttons, and toggle switches, just to name a few. Components in our design system have customized APIs that build on top of their native versions. My iOS counterparts have their library. We rely heavily on the material library, and we build on top of that. So for us, we provide those components to our engineers as specified by our design teams so that when they are used, the resulting UI conforms to our global design standards. At its core, a design system connects designs and features effectively and efficiently. Components used throughout an app should have a consistent look and feel. Components should not look different than if you've got a button on one screen, it should look the same on the other screen regardless of what is actually in the content of that button. Design systems are great at handling changes as well that need to be made across many common components. For example, if a user is using a button that I've built and they've used it on several different screens and we decide, or the design team decides, that we need to change the border of the radius of the border, for example. We can push out that change, right? And now all of the buttons have the new radius at the whim of design. And our team is constantly leveraging that ability. It really is a big win for us when a product owner comes to us and has a new requirement for a component that we've built and is populated throughout the app ecosystem. And we can say, well, it'll take us a couple sprints, but the whole app will receive the update, right? And that's one of the biggest strengths of having a design system library like what we do. And also, I wanted to dive in real quick. I thought this was pretty important. Before we dive into architecture, I like to make this distinction between end users and our users, right? Our end users are the people using the app. They're our customers. This is the Xfinity app, by the way, in the US, but we're also starting to work with Sky as well. But our users are the people we design our APIs for, and they include engineers implementing the features, and that's an obvious one, the designers creating new screens, and a less obvious one that we're wrestling with now is content producers providing content in our CMS. For these users, a good design system means that components are ready to go the moment a new feature starts, so that engineers have all the building blocks they need to make a screen and have that screen connected correctly to the design system and the design standards. They are already designed, built, tested, and meet accessibility standards. So accessibility standards is a big one. Again, especially now that we're working more closely with our counterparts in Europe, accessibility has become one of our #1 priorities when we build our design components so that everything is accessible. Features get to production faster, and once they're live, content managers can update them easily without needing an update to the CMS system to change the data structure. To support all these 3 groups, we focus on creating simple, consistent APIs. That means that consistent component names across design, code, and content make it easier to specify what components to use and what data goes into those components so that they display the content correctly. Consistent parameter names is definitely part of that, as well as consistent values from our token set. Getting to that level of consistency takes a lot of coordination across multiple teams. Right now, for example, we're working closely with our content platform team to standardize the CMS JSON that powers the components and the data that goes into them. I probably could give a whole talk on it, but this is the most important point about who our users are. As we design a smooth API surface, and what I mean by that is consistent naming, we're building a language that we can all speak together. So when I refer to one of our popular colors is purple, and we call it the grimace purple. But when I say theme 1, everybody knows that that's the primary color for our entire design system, right? When I say neutral, we understand what that means in terms of color. And then that goes on and on for textiles as well. But let's jump into the architecture. Since our ultimate goal is to create a great API for our users, here's some insight into how we go about that. We have 2 parts of this, building blocks and API design. Our architecture gives language to designers, like I was saying, engineers and content managers to help them communicate and work together more effectively and efficiently. I'm going to discuss how our building blocks help us work with our design teams to define needs, manage expectations, and even plan work. I'll show you how our team delivers our components and how we design our APIs and think about them so that they are adaptable, accessible, and of course, design compliant. So first, we want to leverage existing components. We ask what already exists. We don't want to reinvent the wheel. Nobody does. If material has the component, and they usually do, we just configure it as needed and layer on top so that our engineers, designers, and content managers know how to use the component. Rebuilding components from the ground up just wastes time. Second, we want to build upwards. So we ask, what patterns do we see? What screens or elements do we keep seeing? And can they be combined in some way? The less our engineers have to configure and build, the faster they can deliver. Similarly, if designers already have a template, designs can be specified more quickly. The simpler the component is, the faster it gets designed, and the faster it gets built. And finally, we want to reduce, reuse, recycle. We often ask, what can we reuse? However, we don't avoid one-off elements, right? So on the one hand, it's a balancing act. So on the one hand, we want to eat our own dog food. When I build a component, I want to see it be used on every screen when it's specified by a designer and implemented by our engineers. On the other hand, sometimes we do get some cool one-off high visibility work, and that's fun. But when we build a new component, we have to consider where and how it will be used and what the context it'll be used in is. And so here's our blocks. These are our basic building blocks and how we organize them in our library. We have the tokens, which I mentioned before. They define color, spacing, typography. Simple content and layout elements like icons, text, spacers, dividers, and headers. Interactive components like buttons, cards, checkboxes, and line items. And yes, I do consider the card to be an interactive element, at least in our library and how we use it. It might be different for everybody's environment. Interactive, and then we pull components and elements together to create patterns like accordion, carousels, our app bar, our alert dialog, and button bar. When we have a full screen of content that needs to be filled with a specific set of content blocks, we like to use templates so that we can leverage scaffolding, sheets, and other navigation elements. So our tokens are automated to generate for all our platforms, including web and iOS, as well as it creates the flavor code base for all of our partner builds. So we're able to define multiple sets of colors, multiple sets of all of our tokens, so that each of our partners can have a unique app experience for their users that reflects their branding, right? We don't need a lot of our own elements, as I said before, and Material provides these for us. And so components are where things get interesting. We consider components to be our more complex interactive APIs. In cases like buttons, we also provide specific brand-related configuration options and styles for designers to choose from, and so that engineers can use them easily. Other components, like our line items, are kind of in a liminal space between a pattern and a component because they're more of a container for content, but they're also highly configurable. For example, line items fits into a pattern for a list of line items, and then sometimes can even be embedded, say, in a card to show more information and make interactions for the users clear. And then finally, we have our patterns and templates. Simply put, patterns are ways to organize components into content slots. We also put our app bar and alert dialog in our patterns bucket. If it requires a scaffolding pattern, then it'll go into our template bucket. The big difference is that they are a full screen set of content for us. In some cases, we also like to use templates as an easy formal touch point between all of our other components and our app's component configuration data. We call this spec data. It helps us keep all data opinions completely out of the main library of our design system, and it stays in the app, right? Our engineers, our users that are using our API, they are responsible for making sure the right data gets into our components. We don't want to be in the business of business logic. For example, templates can include navigation and logging because of these functionalities, whereas a button definitely would not need to be logging anything. We would allow the API for them to provide, they would do the logging through like the callback on click. So now let's talk about actual API design. This is especially important with a design system because of the amount of use each API will see. Our design system is used by a multitude of other developers on other teams, some whom we're very close with, while others I've never even interacted with before, really. And they'll come to me and I'll have to support this API that I've developed, right? So I want to make it as easy as possible for my engineers to adopt the components that we've created. For any API we create within the design system, we want to ensure these three things are true about it. One, it's adaptable. APIs are developer-facing contracts, right? They should be ergonomic to the native component they are customizing and including into the app, and have the flexibility to change for variations in design. If an API is too rigid, it won't get used. They'll write their own code, which is a disaster because, like I said before, when we update that component that they decided to write on their own, it won't get any updates. But on the other hand, if it's too flexible, it'll be abused. Two, they're accessible. Like I said before, this is a high priority for us. We want everybody to use our app, regardless of any kind of limitations that they might have. They have to have, and they have to have it out of the box. The only accessibility we want our users to worry about is that of the entire screen where the component's being used. So again, we can use modifier for a lot of our accessibility stuff, but when it comes down for like screen readers, for example, we have to make sure we're on point with all of our content description handlers and parameters. Oh, and compliant. They're design compliant, right? We have a global design system for a reason, and so we want all of our components to be accurately specified and implemented. And it saves time for everybody to have it do it this way, so that they don't have to be concerned with an individual component. Again, we really want our users to be able to just use our buttons, use our containers easily and effectively. On top of those requirements, we stick to these three guiding principles when designing new APIs. One, they should be smooth. Components should have a clear purpose and structure. These customized APIs should resemble the native components they're building on top of. The language should be the same for all of our users. That's what I mean by it being smooth. If I name a component big button, say for example, if I name a component big button, I would expect that the designers would put that name in their documentation when they deliver it to the engineer, so that the engineer doesn't really have to think. They can just start typing and the IDE does the rest, right? They can see the button component. They have the data readily available. And the same goes with the CMS. This has been an interesting one. If we don't name things the same in the CMS, they get a mess of JSON, and then I have to work with the engineers to figure out what fields in the CMS JSON go into what parameters in my API, right? We try to avoid that. And again, it's about building a common language for all three groups of people to come together to build these parts of the app. Second, APIs should be simple. We simplify method signatures by providing overloads that set default values, right? Love this part of Kotlin that we can do this. And by creating increasingly simplified methods, we rely less on a single large method with a lot of parameters. The single large method should remain public and usable, just in case a more customized component is needed from that API. We see this pattern used a lot in Material, which is why we try to follow it as much as possible. And finally, APIs should be explicit. When designing an API, naming should be explicit and obvious. Parameters and helper functions should be named for what they do. Custom API names should include the name of the native component they're customizing. Finally, they should not hide any functionality or be magical, right? Pretty simple. But so here's an API design example for us, is our text input. And each of these elements is a customizable parameter. So we have the text field itself, the labeling, the leading icon, help text string, and the hint string, as well as a trailing icon for hiding or clearing the value, right? But we also end up providing some helper functions for these elements, like the trailing icon. Its primary use case will either be as an X icon to clear the text field or as an I icon to reveal the password text. And we use those helper functions and we provide those to it. But then we would build another method on top of this, right, that automatically plugs it into the content slot, as I'll show you here. So this would be like a full method signature with a value and on value change. And I've shaded the parameters in yellow that are standard for either all the components, like modifier, text inputs, and keyboard actions. And then what we're left with is all the design focus parameters. Text style will change the style of anything typed within the text input. And the validation state is for our engineers to use to tell the button how to appear depending on the text validation or the text that they're trying to validate. And then our tone. For colors, we use this tone word. We're actually, I'll show you it. I'm going to show you our button next. And we're changing that to be color because, like what I've said before, nobody really knows what tone actually means. It's much easier to call it a color. So here we'll jump into a recent case study for us, buttons. Buttons were our first addition to our shiny new Compose library, and here's an example of what that API looked like. In general, this is a standard button, right? The API fits over top of materials button, and it has a modifier, a click listener, and all the things that style the button and populate it with content. But highlighted in red is the real big problem here. When we first wrote this button method many years ago, for some reason, we thought it would be a good idea to put all of our buttons under one umbrella, right? Sort of omni mega button function. And it created quite a few headaches in terms of maintenance. For example, if we needed to change the method signature of one of the internal methods for a variant, like fill or outline or text button, we had to consider its impact on the main function's parameters. Additionally, our engineers and designers, they know material and Compose API guidelines lean towards more explicit, discrete, and logicless methods. So it began to get confusing for our engineers as to whether they should use this main function or one of the other functions underneath it that rendered out the specific variant. And finally, the configuration was actually too strict. The tone, and I'll show you in the next slides, but that tone and the button size was actually an evolution because we kept getting requests that how do I change the padding? How do I change the size? Those sorts of things, because corporate designers try to think outside the box and don't always stick to their own standards. So we did want to have some additional flexibility there. Now we have individual methods, just like the material library, with distinct default objects. This makes it much easier to build new button variants and add style changes at the same time because we've inverted that relationship and made the implementation and usage context explicit so that they're much clearer. Default objects are static and extensible from a copy method. Again, that's a pattern that we see quite often in material. So our engineers are already very comfortable with that kind of a thing, if they even need to use it. Hopefully they don't. However, it does still allow them to easily be modified if they aren't happy with the default. We also provide a bare minimum of defaults, though, only to support the design system. Designers, like I said, they often go off the beaten path, and this just provides early warning that they're out of the system. If an engineer is having to ask the designer or me where something is, or what it's called, the designer usually has spec'd it incorrectly. In some cases, we file a bug report as well, and we have to fix our code. But again, that's why we try to have all of our naming in line and the same across all working fields. Each button has these parameters, right? So we have the fill button, outline button, text button, filter buttons. They all have the same parameters, set of parameters. They're just the configuration object is what differentiates them. And then internally, when we use the material API underneath it, that's when we apply those configuration effects. And then, yeah, just kind of how we organize them. I'll show you, though. This is what it ends up looking like for our outline button. I've changed the names. Obviously, we don't call it outline button because that would conflict with material, but for purposes of copyright, I guess. Outline button, this is our new API. It's not a huge change on the surface, as you can see, but moving to our explicit method architecture is a huge improvement. Note the defaults object, we'll get into that later. Our defaults object has shortcuts to each variant. So here it says button defaults, outline button colors dot neutral. Actually, there is also an outline button defaults, and but what we decided was to centralize everything so it's easier to access and more consistent. And This API is an example of what we would call a slotted API. These are an important tool for us because they provide a high level of control and flexibility to our users, but with great power comes great responsibility. So we typically refer our engineers to use our explicit APIs, which I'll get into in a little bit. Slotted APIs are simple. They should always include a modifier parameter. We'll include sizing configuration parameter, render slots with nullable logic only, and in some cases may need some simple data. This is like a graph that we've made for our users, and it's just a real simple, well, it's called column. It looks like a row, but it's actually a column because we stack those, the text on top of the actual bar. But you can see here how we're using the slots to, with helper methods, to be really explicit about what it's supposed to be and what it's supposed to show. All right, and so this is an example of our simplified explicit API. We really like these APIs because they fit nicely with our CMS services or other applications where the engineers may not want to or just are not able to create a full content composable to go into the slot, right? So we usually recommend these over the slotted methods for ease of use to ensure conformance to design standards. We chose not to further simplify this thanks to the Kotlin parameter defaults alleviating the need for overloads. When we do a simplified version, we try to use basic data types, so like string, integers. We have a icon class because we automatically have automated our icon generation process. And then again, there's our configuration, which is overridable, and so our engineers and designers, if they need to tweak it, they can. As opposed to slotted APIs, our explicit APIs are much less flexible, right? Because you can't just jam in any content into the slot. Often they're helpers for a slotted API. While we prefer not to use scopes just to strongly type stuff, it can be used that way. Otherwise, our helpers are just left just simple composables that emit UI for a specific intended use within the larger context of the component that it was designed for. In addition, explicit APIs help us with our CMS use cases, like I said. Our default objects are the other major change to the API. We wanted them to be objects that are easily accessed and modifiable. We really like the shape of Material's button default object, so we use that for inspiration. However, our button default object is really a collection of shortcuts, like I was saying earlier. This is an example of the outline default object. Theme 1, like I was saying, as well, and neutral color sets. That's where we would plug in the actual colors. For brevity, I just snipped it out. But you can see in our library, it looks like a lot of code. I mean, it is a lot of lines of code. But then if you can imagine being an engineer and implementing this, it's much easier to type that out and access it. While we do build our components to be logicless, sometimes design specifies states or other groupings of colors. And in these cases, to provide consistent and accurate color schemes for the component, we provide enumerated default sets to the developers so they don't have to. And this is just an example of how we would go about that with our colors object and its related defaults. And then we just wrap it up in an enum so that they can easily do a when statement and choose the correct state for their component depending on what the user is doing or what state the app is in. So to wrap it up, lessons learned. Avoid using DSL structures. They should be rarely used. I definitely have had to back out quite a bit of code because our engineers couldn't find methods within a scope I had designed. unless it's something like lazy list, where the content's acquired lazily for layout reasons or efficiency. Also avoid creating APIs that are classes with a composable content method. We just found that difficult to maintain, honestly. It's much simpler to just have a compose method do everything for you. And both of these structures, one of the big problems we have is they create unnecessary complexity when most of our users just want a single function that renders out exactly what they want. And it hides functionality from anyone looking to implement our APIs. So we have to field a lot of questions and do a lot of support. We ultimately found that the best structure is basic composable function. We like it, it's simple, it's powerful, it's easy to understand, and going back to kind of the main theme of what I do is, it really creates a common language for designers and engineers to use. And I'll go back to that content method situation. Designers don't know how to talk like that, right? And nor should they have to. What they really just want to know is what the name of the what the name of the component is, so that the engineers can implement it. Like I was saying, we just want our APIs to be clear, simple, and obvious. So that's my talk. Thank you very much for being here. I guess I'll open up for questions. I lost track of time. I'm sorry. No, we do. We have one design system for all the platforms. They do deviate when it makes sense for the native component to be used. Yeah, we're pretty flexible about that. Like I was saying before, if it exists natively, we try to use it. iOS probably more so. Probably at this point uses more native. We love the flexibility of Compose. We just wrap right over material stuff. That's all we have to do.
Because I guess my follow-up would then be, because you also had patterns and templates that's part of your system, and they, I assume, can be quite different across iOS and Android.
It's definitely on my bucket list to be more familiar with our iOS side of the library, my counterparts on that side. But we do, when we plan new work, we sit down together so that at the very least the naming is the same for both platforms. Yep.
One question about, do you deliver this as ARs?
Right, yeah. Mm-hmm. We're a standalone library for the app so that we can distribute to other app platforms as well.
Okay, and how do you handle binary compatibility, or do you have issues?
So we have had ABI breaks in the past, but I forget the name of the tool we use now, but it's basically the command is Gradle W API dump. Yep. That creates a diff in GitHub for us where we can see, and basically kind of our rule is if we see any removals, we have to go through and we have to go through and check it for ABI compatibility. I will say the new compiler has started adding identifiers onto the parameters so that doesn't happen anymore.
Okay.
We still use API dump, but what I've noticed since we updated our compiler, I think it's the compiler, forgive me, it's putting in like one of those 6-digit hashes, and that has seemed to help us avoid that problem, right? Because then it has that specific identifier.
And did you have issues if you update some of the libraries, like Compose, and the app has different Compose version, or?
So, yeah, our developer experience team handles that for us.
Okay.
So yeah, I don't even have to worry about that.
Okay.
Basically, when we merge, we can publish from GitHub. We have an action for it. And then we have a Renovate bot. I don't know if you've ever heard of that. We use Renovate. And it will automatically create a PR in the main app, and vice versa. So any kind of Gradle version, AGP, all those are kept in sync using Renovate.
So okay. But the teams are in the same company. So the app team is in the same company as you.
Okay. Yeah, they're my counterparts. My team's called Design Infrastructure, and I think that pretty accurately describes what we do. We provide the infrastructure for the design team to deliver to the engineers.
Okay, all clear. And do you have some restrictions from the designers? Like you mentioned the API with slots, but do you get sometimes the restrictions from the designers? You're not allowed that they want to reflect in the code, so you're allowed only to put some type of icons or some type of.
Yeah, and that's an important part of what we do in terms of designing the API. Right, is just like any user experience, if the user can't do it and they want to, we want to make sure that it's because they're not doing it right. Okay. Maybe the feature designer did something wrong, and then the engineer says, well, how do I put this content into that slot for that component? Yeah. And we say, well, you're not supposed to. So then the designer has to go back and rework their designs.
Yeah, exactly. Yeah.
That's a pretty common, happens quite a bit.
Yeah, same.
Oh, I'm getting the signal to wrap it up. So thank you guys. Thank you everyone for being here and listening to me ramble on about it. But I hope you enjoy the rest of your day. Thank you very much.